B, C. All right. And it moved and I can't see now. All right, cool. Alicia, take off. See ya. Have a good one. All right, look, we have 62 degrees, 22.6 miles. Oh, there's Colin. I have to, okay. I have to. All right, here we go. So what we need to do is we need to figure out this side length, and this angle. Let's find the angle first because remember, all the angles in a triangle add up to 180 degrees. So I know that this is 90 degrees right here because that little box tells us. So 62 plus whatever this is has to add up to be the other 90 because if this is 90, then these two have to add up to 90 to give us 180. So I'm going to go ahead and do that. 90 minus 62, that's 8, that's 1, that's 8, that's 2. So this is 28 degrees. Now, even though that's 28 degrees, I'm still going to use 62. I'm still going to use 62 because I'm 1,000% sure that 62 is correct because they gave it to you. It was part of the problem. That's what they said. They said, this one's 62. Okay, I figured out 28, but I'm still going to assume that's 62 and use this as my theta. So this is theta. And then we'll go in and we'll label the opposite because it's opposite of theta. We'll label the hypotenuse. We'll label the adjacent. Okay, so think of this as a projector. It's a projector. And where does the projector project? Onto the opposite side. Okay, so now what we need to do is let's go ahead and find what the, let's find the adjacent. We never go after the adjacent. So if I am going after the adjacent and I'm going to use the opposite information, which trig function should I access to find this side? What do you think? Let's see. If we have opposite and hypotenuse involved, we use the sine. If we have the adjacent and hypotenuse involved, we use the cosine. If we have the tangent, if we have the opposite and adjacent involved, we use the tangent. Okay, so it's all in relation to the opposite, the adjacent, and the hypotenuse. We're just seeing what sides are involved to tell us which trig function to use. So for this one, I'm going to use the tangent because it's adjacent and opposite. Opposite, adjacent, opposite, same thing. So watch, tangent of 62 degrees is equal to the opposite over the adjacent, the opposite over the adjacent over hypotenuse, the opposite over the hypotenuse. The letters tell you what goes first and what goes next. All these kids coming in late. Guys, did you guys get released from another class late or something? I don't know. All right, so let's go ahead and set it up. The opposite is 22.6. The adjacent, we're just going to call it adjacent. So now I don't really need that guide anymore. Okay. So we have the opposite over the adjacent. And now what we're going to do is we're going to go in and we can work out the tangent of 62 degrees. It's in degree mode, DEG. So we're going to go 62 tangent. And we get, is that right? 1 sec. 62 tangent. Yeah. We get 1.88 is equal to 22.6 over the adjacent. So I'm just going to go ahead and put it over 1 so I can do, okay, it was a quiz. I think people were finishing the quiz. Thanks for letting me know. I'm recording this too, so it's just going to go over a couple problems for trig review. You can check it out in the stream after class if you need it. Okay, 22.6 is equal to 1.88 times the adjacent. I want to know the adjacent, so this is where I need to divide by 1.88. If you find a shortcut to this, it's fine to use it. Just showing cross multiplying. Most people know it. All right, 1.88 over 1.88 is 1. So I know my adjacent side is going to be equal to whatever this is. 22.6 divided by 1.88 is 12. 12. We'll go 12. It's 12.02, but we're going to go 12. I'm just going to say 12.0. So look, 12. Nice, nice. All right, let's see what we have. We have these angles figured out. We have this side and this side figured out. We need to figure out the hypotenuse. 2 ways to do it. You could do the Pythagorean theorem 12 squared plus 22.6 squared is equal to the hypotenuse squared. But let's go ahead and use, let's use trig since we're doing it. And here's what I'll do. I'm going to use this angle, that angle, and I'm going to use this side again. Because 12 I'm pretty sure about, but I'm 1,000% sure that 22.6 is correct. So if I want to know the hypotenuse, I'm going to use opposite and hypotenuse. Let's see which one we use. Opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. Opposite, hypotenuse. So I'm going to use the sine of my theta, 62 degrees, and that's equal to the opposite over the hypotenuse. Opposite is 22.6, hypotenuse is hypotenuse. All right, and then 62, the sine of 62 is 0.88. 22.6 hypotenuse. Let's go and throw it over 1 and just cross multiply. (22.6) is equal to 0.88 hypotenuse. 0.88. 0.88. Bye. Hypotenuse is this. 25.7. Oh my God, we did it. Oh my God. We have everything we need in life. And that only took a whole page. All right, thumbs up, sideways, down. What do you think? Thinking pretty good? Feeling pretty good about it? All right. I can't wait to be in the class again, guys. Can't wait. You too, Alicia. All right, so how about we do one more and we call it quits. Okay, great. Have a good day. If you need to take a screenshot for number 17, now is your chance. In 3, in 2, in 1. And now let's see, I'm going to try to find the hardest one in here. They're all exactly the same difficulty. Let's go with then an easy number to work with, like number 23. All right, this is the last one I'm going to do, and then I'll dismiss y'all. So hold on for, let's see, we got 15 minutes. I'm going to try to do this one like 5 minutes. All right, 23 has this triangle. How do I draw in triangles so amazingly beautiful? Well, stay up late, practice my triangle skills. All right, excellent, good, I did it. All right, look, here's our angle. If this is my little projector, where does it project? It projects on the opposite. You see? Always easiest to put the opposite in there. And then the hypotenuse is kind of like, duh, it's across from the right angle. And then over here's your adjacent. And you're like, well, that's the one left over. And adjacent's hardest to see, so I'm glad it's left over. All right, look, that's 90 degrees. That's 40. Since these two have to add up to 90 for the whole thing to be 180 degrees, this one has to be 50. Right? 50, 90, 180. All right, still using this. Still using 40. And let's go ahead and find the opposite first. I'm going to find the opposite, and I'm going to use the hypotenuse. So we go back to our so, ka, to, and which one are we going to use? What's involved? It's always about what's involved. You can choose. Like we could have gone after the adjacent. That would be something different involved. But here what's involved is the opposite and the hypotenuse. The opposite and hypotenuse. Opposite, hypotenuse. So we're going to use a sine. We're going to do the sine of 40 degrees. Remember, that was my theta. I'm using what they gave us. Sine of 40 degrees is equal to the opposite over the hypotenuse. The opposite we don't know. We'll call it x. Opposite over the hypotenuse, 3. These are going to be much quicker. Now look, 40 sine. We get 0.64 is equal to x over 3. I'm calling this, calling that x. And then we will multiply by 3. Bye. This times 3 is x is going to be equal to 1.93. 1.93. Okay. All right. Well done. We did it. Now I'm going to use hypotenuse and I'm going to find the adjacent. I'm just going to label the adjacent y. It's the y-axis anyway. Okay. And now that I'm using in reference to my same theta, always keep the same theta, I'm dealing with the adjacent and the hypotenuse. Let's see. Opposite hypotenuse, adjacent hypotenuse, yep. Opposite adjacent, nope. Adjacent hypotenuse, yeah. So let's use the cosine. Cosine of 40 degrees is equal to the adjacent y, adjacent over the hypotenuse. Okay, 3. Let's go ahead and do this one. We have 40 cosine, and we have 0.77 is equal to y over 3. Last step. Let's go ahead and multiply by 3. Out. Y is equal to 2.3. 2.3. 2.3. Nice. Let's see. Did we get all the sides? 3 centimeters, 2.3 centimeters, 1.93. Yep. We got all the angles. 40, 90, 50. Yeah, we got everything. That's it. Oh, that's how it works. Yep. All right, I'm going to stop the video and check in with